Hello, welcome to 8.7 Surface Areas of Pyramids and Cones. Okay, so just a reminder, pyramids have a polygonal base, and they all of the lateral sides go to one point, where a cone, the base is a circle, and again, all of the lateral sides go to one point. So the relationship between a cone and a pyramid are, very similar. If you think of a pyramid as a special case of a cone, where the simple closed curve of the base is a polygon, you'll think those are the relationship between the two. So, just in case you could also think, I guess, of a pyramid as or a cone as a special case of a pyramid, however you want to think of it. Typically, you think of it the other way, that a pyramid is a special cone. But again, it's however your mind can remember it. So right away, the thing we need to talk about for a three-dimensional figure is the altitude. The altitude of a pyramid is the segment that goes from the middle of the polygon or the circle, and it goes all the way to the top, to the point. It's perpendicular to the base. So I don't have an altitude drawn on this figure. So we can still find the surface area without the altitude of the figure. The altitude will be more important when we talk about volume. Also, a regular pyramid, you just want to review that real quick, is a right pyramid. So it has a right angle from the base. So that point is directly over the center. So if that point at the top of the pyramid is skewed at all, you don't have a right pyramid. Okay, so what we don't know or haven't talked about before is the slant height. Right now I do have the slant height drawn on this figure. It's the one that has the right angle attached to it. That's basically the altitude of the lateral triangle here. So that is the slant height of a triangular face pyramid is going to be helpful to us, because we can use that slant height as the height of that triangle. So let's get started. Okay, so the area of a triangle is half base times height. Now if you look here, we have 5 triangles as our lateral surfaces of this pyramid. So if I use 16 as my height and 7 is the base, if you notice that, so the side of the polygonal base is also the base of the triangle. And so now I have an area of one of those triangles. Now I have 5 of them, right? I have 5-sided figures, so I have 5 triangles. So I know the lateral surface area is 280 square units. Now remember, I need to find the base as well. So that's half apothem times perimeter. And I have both given to me. The perimeter is 7 times 5, which is 35, and then my apothem is 4.8. So now I have the area of the base, and I need to add that to my lateral surface area. I only have one base, so together they're 364 square units. So as you notice, I took apart this pyramid of all the surfaces that I needed to find. So in general, the formula for the lateral surface area of a regular pyramid is half base times slant. That's what that L means, the slant, times the number of sides. Okay, so B is the length of the side of the base, N is the number of sides of the base, and L is the slant height. So if you look at that, that's really still perimeter times the slant height. So we can simplify that even a little. Because base times slant height is still, base times number of sides is still perimeter. Okay, so that's where this P comes in. Perimeter times slant height. Okay, so let's do another one where I don't have the apothem. Okay, so here if I use the perimeter, 12, and it times how many sides, which is 6, and then so 12 times 6 is 72, and then 23 is my slant height. So that will give me just my triangles on laterally. Now in this case they're going to go ahead and find the apothem. So remember that goes from the center to the midpoint. It's perpendicular bisector of one of the sides. So I'm creating a little mini right triangle. I know that half the side is 6 and that the radius is 12. And the reason why I know that is because this is a hexagon, and a regular hexagon creates equilateral triangles. So you don't always automatically know the radius, but on a hexagon you do. It's the same as the side lengths. So there's another little trick for this particular problem. Okay, so then I go ahead and take the squares, I subtract the 36 from the 144, and then I have just the apothem. Now I have to plug that number back in to my area of base. So area of base, half apothem times perimeter. I now have my apothem and I have my base. So now I need to add that to my lateral surface area. And therefore my surface area of this pyramid is 1,202 and 4/10 square units. So lots and lots of steps, tons of places to mess up. So it's really important that you go back over, you go slow and steady, and not rush yourself. Okay, another theorem we're going to have today is the surface area of a cone. Now, the premise is exactly the same. You have to find the lateral surface area plus the base. But remember the base is a circle, so we have a little tiny bit, instead of having a perimeter, we have a circumference. So the formula looks just a tiny bit different, but it's exactly the same concept. Okay, perimeter and circumference are the same, it's just a different figure. Okay, so let's work this example. Okay, the lateral area, surface area, is pi times radius times slant. Now that 18 is the slant. The base we know is pi r squared, and we're going to add those two together, right? And the exact answer is 144 pi. If you want to go ahead and multiply that pi, you could go ahead and round to the nearest hundredth on that, but why not just leave it in terms of pi? Okay, so this slide is a summary of today's lesson. Although we did touch on some of these concepts in 8.6, it's nice to have all of your formulas in just one place when you're talking about, when we start to do some homework questions, right, out of our textbook. We'll have the pyramid and the cone all together in the same place. So I would, put a little box around these in your notes. It's just easier to find them when you need them. Okay, so I want you to look up and write the definition of these two terms, the ellipsocoid and the hyposilicoid. Now, both of those are plane curves, and if you use a good math website, of course you can use the internet, and Google is your best friend again, but I want you to write the definition in your own words, and I want you to sketch something. If you sketch something you found on the website, go ahead and give credit for it though, so you're not plagiarizing. I'm good with that, just don't print it out. It's got to be your own work, and I will see you in class.